Hi everyone, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. Yes, students, am I clearly visible and audible to you or not? And today we are going to do mole concept and stoichiometry, like one of the most important topics for your physical chemistry, right? And for this chapter, right? Reason being because mole concept is not only used in mole like this chapter, it is used throughout your chemistry. Sometimes they give you questions in the mixture of organic chemistry plus mole concept. You know, if they can relate mole concept with any other concept like organic chemistry, inorganic chemistry, that's why they ask you mixed questions also based on that, right? So for that mole concept stoichiometry, right, that is a little bit differences there that you'll understand by doing the questions, right, that we are going to see today, right? And you know what, very happy I am, like by looking at the amount of students who are doing their homework. You have actually made me very happy. So, one announcement for you. We have already see one thing is in your, because in the first lecture, law of chemical combination, you have done this much, right? These students have completed, wait a minute, yes, Avengers, then you have Lalhuru, then Futuritian, then you have Goa, Anant, and Mr. Sharma, right? So all these students have done their homework. So I'm very happy about it. So one thing is I'm setting up the target. If you give, like if 15 plus students do their homework, and homework means you have to write it in the comment section, right? Then I will start providing you DPPs. Okay? I'll start providing you DPPs of every single lecture, right? DPPs of every single lecture I'll provide you. But for that, you have to firstly prove yourself, because I know that by looking at this, I can see that you have the potential to prove yourself. So that's why I wanted for you that you start doing the DPPs as well, that I will provide you. Don't worry about that, right? All you have to do is 15 plus comments regarding homework. That should be there in the comment section. Okay. Yes, everybody. Yes, everybody. Now let us start the session. Now, if you talk about the mole concept and why you were saying that this is so important for you. First reason is why it is so important. 47 questions in last 10 years, and it also has questions not only directly, indirectly as well. They are asking you question based on mole concept, forms a base of physical chemistry and reoccurs throughout the chemistry. It reoccurs. That's why this becomes very important for you. Okay, so everybody, and one more announcement for all of you, right, that we are coming to your city, that is Hyderabad and Chennai. You can see Madhupur and Anna Nagar. We are coming, and we are so excited to meet you guys there, right? That the students who are right now confused that whether they should take drop or not, those kind of students can come and join and meet us. The students who are sure that ma'am, I want to take a drop, but I don't know what is the path that I should follow, then students, we are going to select, like some students will be there in the rig batch, that is rank improvement batch, right? For there we are providing 100% fees refund, or your rank improvement will be there, like 100% guarantees there, right? So for the selection, you have to firstly visit and meet the teachers. They are coming to your city 5th July 5 p.m. and 6th July 6 p.m. Okay, here first is Hyderabad, and 5th July it is Hyderabad, and 6th July it's Chennai. Okay, yes everybody. Now let us start our session. Now, before starting the session, this session is full-fledged what you need for your exam, right? So, starting with mass in AMU and gram, firstly, you need to understand the difference in AMU and gram, right? So, I'll be taking one example here. Let's take one example. Let's take the example of N2, okay? So, if I say that I have nitrogen atom, if I say that I have nitrogen, I have, let's say, I have 1 mole of, that also I'll tell you what is 1 mole. Now you just understand what is this, right? 1 mole is some fixed quantity, right? So when I say that 1 mole of nitrogen atom, 1 mole of nitrogen atom, right? Here I am saying that you have N2 molecule, N2 molecule, and here I am saying 1 mole of N2 molecule. Okay. So whenever I am writing the nitrogen atom, if I am just talking about one nitrogen atom, right? Whenever you pick up an atom and you want to calculate the mass of that particular atom, that is going to be very small. Okay, very small. So instead of writing that in grams, we write that in nitrogen atom has 14. 14 means 7 electrons and 7 protons. So that is total 14. But ma'am, 1 mole of nitrogen atom, it also has the same amount of mass. But the change is, over here you have AMU and here you have grams. This is also written as 14 gram per mole. This is also written as 14 gram per mole. Now understand the difference. The numeric value of one atom or 1 mole of atom is same. If you have one atom or if you have 1 mole of atom, the numeric value is going to be same. For example, for oxygen, it will be 16 and 16. But the units are going to change, right? How the units are going to change? Here it will be 1 AMU, here it will be gram per mole. Now the question will arise in your mind that, ma'am, what is 1 AMU? Ma'am, you have written 1 AMU. Ma'am, what exactly is 1 AMU? Right? AMU is the unit of one mass. It is called as atomic mass unit. It is called as atomic mass unit. And if you see this now, what is the definition of this? It's not like it was easily told that 1 AMU is this. No. 1 AMU has a lot of history it has, right? So what happened? Firstly, they were thinking that we usually compare hydrogen to find out anything, right? If you talk about in electrochemistry also, to find out the reactivity series, you talk about compare it with hydrogen. So firstly, scientists thought that let's compare it with hydrogen atom, right? But it was not successful. Reason being the masses were, because see, to find out one atom, right? The mass of one atom, which is very, very small, it was very difficult. So you need to compare it with something. So firstly, they thought that let's compare it with hydrogen. But when they compare it with hydrogen, the masses were coming out to be fraction. That's why it was eliminated. That, okay, hydrogen is not a preferable comparable unit, right? Then they thought that what else we can do? Then we know that oxygen is something we inhale. Then they say that, okay, let's compare it with oxygen. Okay, let's compare it with oxygen atom. Now, after comparing with oxygen atom, the real struggle was that oxygen atom is of two types, right? We know that there are two isotopes of oxygen atom, oxygen 16 and oxygen 18. Now, scientists forgot to mention that which isotope they are comparing it with. Some countries in some zones, they were thinking that it is comparing with oxygen 16. Some are thinking it is comparing with oxygen 18. Then they also clarified that we are comparing with oxygen 16, bro. But everyone is like, you had done a mistake now. Now nothing can happen. We will not accept this because you have not mentioned anything. Then the third one and the final one was your carbon 12 isotope. That's why if you see, it is specially mentioned that which isotope they are talking about. Carbon 12, carbon 13, carbon 14. We always say carbon 12 isotope we are talking about, right? So that is your carbon 12 isotope. Now understand one thing. When I'm talking about carbon 12 isotope, very important thing to remember, that how do you define 1 AMU? How do you define 1 AMU? So I'll write it here. 1 AMU is defined as 1 AMU is 1 by 12th mass of carbon 12 isotope. That is your 1 AMU. That is 1 AMU. Right? This is what definition it is given to you. That 1 by 12th mass of carbon 12 isotope. Now you will think, ma'am, why only 1 by 12? See, we know that what exactly is it? Carbon has 6 electrons and it has 6 protons, right? So answer becomes 12. So they thought that if I consider, okay, just imagine one thing. They were thinking that what should be a standard, what should be a fixed standard. They thought that carbon is having 12 electrons plus protons. If we consider carbon as 12, carbon they have fixed to 12. Then if we, because hydrogen is 1, protons plus electrons, in protons plus electrons, why I am adding protons plus neutrons is 1, right? Because in hydrogen there is no neutron, there is 1 proton and 0 neutron. So it is going to be 1. In carbon it is 6 neutrons plus 6 protons, it is 12. So they fixed the mass of carbon 12 isotope as 12. Now 1 by 12, because this is 12, this is 1. Here neutron plus proton is 1. Right? So that means this is 1 by 12. And that's how the definition of 1 AMU became 1 by 12th of carbon 12 isotope. Right? Tell me if that is clear to all of you or not. Tell me, student, if that is clear to all of you or not. Now, I'll tell you a very, very interesting thing here. Tell me one thing. What is the mass of carbon 12 isotope? What is the mass of carbon 12 isotope? That is 12 gram. Okay. Now, when you compare this, can I see mass of one atom of hydrogen, one atom, or you can just simply say this thing also. This is 12 gram. Achal, theek hai. Now, if I want to calculate mass of one atom, not one atom, right? We are talking about 1 mole only. Mass of, let's say, mass of 1 mole of carbon 12 isotope is 12 grams. Right? If I say mass of 1 mole of hydrogen 1 isotope is 1 gram. Right? That is 1 gram. Now mass of one atom, 1 mole is mass of nothing but 6.022 into 10 raised to 23 hydrogen 1. That is 1 gram. Now ma'am, what is 6.022 into 10 raised to 23? For that, you have to understand this particular thing. That whenever I am comparing 1 mole, it's just that the things we do in our daily life. If I say I want to have 1 dozen of eggs, you say 1 dozen of eggs, or you say 1 dozen, or you say 12 eggs. The shopkeeper will understand that you're talking about 12, right? Similarly, if I say 1 pair of shoes, now nobody has in 1 pair you have 2 shoes. Now nobody have in 1 pair 5 shoes. No, it's not there. We know that in 1 pair it is 2 shoes only. It is fixed. It is fixed in our head. Similarly, 1 gross pencil. Gross means 144 only. Right? That is 12 square. That is gross is final by that. So these terms are fixing the number of particles. Similarly, 1 mole of atoms, or you can simply write here particles. 1 mole of particles are fixing 6.022 into 10 raised to 23 atoms. It is fixed that this amount of atom they are talking about. Okay. Now, coming back here, mass of 1 mole of hydrogen is 1 gram. Okay. Now we know that 6 plus 6 is 12. So that's why mass of 1 mole of carbon 12 isotope is 12 grams. Mass of 1 mole of hydrogen will be 1 by 12 of that is 1 gram, right? Now understand one thing. Mass of 6.022 into 10 raised to 23 hydrogen atom is this. So that means mass of one atom is equals to 1 by 6.022 into 10 raised to power 23. That is nothing but 1.66 into 10 raised to power minus 24, and it is in AMU because here you are talking about one atom, the mass of one atom, right? So that's why it is written that mass of one atom is considered in 1 AMU, right? And 1 mole is considered in grams or gram per mole. Keeping numeric value same. Keeping numeric value same. Okay, understood what is 1 AMU, what is gram, right? Numeric value will be same, but the units will change. Okay, and 1 by 1 AMU is nothing but 1.66 into 10 raised to power minus 24. What is N2? What is the mass of N2? If I talk about one molecule of N2, that will be see, it is 14 into 2, 28, right? So I'll just write it by this. That is 28. Instead of writing atomic mass unit, we just write U, because atomic mass unit is for atom, right? So for molecule, we have simply written it as unit, just to simplify that thing, right? EMU and U has the same value, right? But it's just that the way of writing is differentiated, because EMU they have put it for AMU, right? Then they thought that for one molecule we can't write atomic mass unit, so they have just replaced it by U. Now numeric value will be same, but it will be gram, or you can say 28 gram per mole. Okay, understood? Now in the mole concept, you will also use molar mass like throughout the mole concept. What is molar mass? Molar mass is, for example, they talk about H2. Now H2 has 2 hydrogen and 1 oxygen, so it will be 2 into 1. 1 is the mass of hydrogen, plus this will be 16, that will become 18. Now if you talk about one molecule will be 18U and 1 mole of molecule will be 18 gram. Okay, so that's how we write our molar masses, right? Molar mass is nothing but we talk about 1 mole of molecule. Okay, that's why this is the molecular mass. Molecular mass. Students usually take molar mass and molecular mass are same. No, molecular mass means one molecule, right? And molar mass means the mass of one mole. Okay, molar mass means the mass of one mole. Okay, students, right? Now let's move ahead, right? Let's move ahead. Now we will talk about mole concept, because you have understood what is one mole and what are the important terms to understand before going through the mole concept. Now let's understand one mole is simply a unit for counting entities, right? Just like you are counting that 12 eggs you have, 12 bananas you have, that means 1 dozen. Same way, we are saying one mole is nothing but 6.022 into 10 raised to power 23 particles, right? Now understand one thing, this many particles is nothing but this is also called Avogadro's number. It is represented by Na, and this number is not specifying that I am talking about particles, I am talking about ions, I am talking about electrons. This means I am talking about any general particle. Any general particle. Now these particles can be atoms, these can be molecules, these can be ions, these can be electrons, protons, neutrons, anything, right? That means if I say you have 1 mole of CO2, that means 6.022 into 10 raised to power 23 CO2 molecules. If I say you have 1 mole of hydrogen atom, that means 6.022 into 10 raised to power 23 hydrogen atom. If I say you have 1 mole of Al3 positive ions, that means 6.022 into 10 raised to 23 Al3 positive ions. If this much electron means 6.0 10 raised to 23 electrons or protons or neutrons, whatever we are talking about, right? So we are just specifying that particles will be there. Whether it's atoms, molecules, that we will see, right? Now, this is a very important line that can be asked in your statement based questions, okay? So usually students find mole concept difficult because these things are not, they are not able to understand. It's actually very simple. Understand one thing. It is the amount. What is actually 1 mole? It is the amount of substance that contains as many species as there are atoms in 12 gram of carbon. It's just a way of writing things. See, we know that in 12 gram of carbon 12 isotope, how many atoms are there? They can also write here 16 gram of oxygen 16. They can also write here 14 gram of nitrogen. That is the same thing. But why they have written carbon only, I told you. That they wanted to have one specific thing, that is the standard. Now, because they have taken standard as carbon 12, they will compare everything with carbon 12. It's not like you can't write 16 gram of oxygen 16. But this, the scientists have not given this thing. See, logically this is right. Logically this is right. But the scientists have not given in with respect to oxygen or nitrogen. They have given with respect to carbon. So we will learn the definition of carbon only. Right? Okay? Understood? That means the amount of substance. See, we know that in 12 gram of carbon 12 isotope, how many particles? 1 mole is there. That is nothing but 6.022 into 10 raised to 23 particles, or here we are talking about carbon 12 atoms. Next important line is reciprocal of Avogadro's number is known as avogram, right? That means now one thing is, usually students get confused in this thing, right? Understand one thing very carefully. I talk about reciprocal of this, that means 1 by 6.022 into 10 raised to 23, which is equals to 1.66 into 10 raised to minus 24. This is called reciprocal. Reciprocal of this is called avogram. Avogram. But you will think that, ma'am, this is nothing but, ma'am, 1 AMU only. See, again, don't get confused here. The numeric value of avogram and AMU is same. What I am saying, the numeric value of avogram and AMU is same. But avogram and AMU are two different things. Avogram, we are simply saying reciprocal of Avogadro's number. Right? Just number, we are taking reciprocal. That's it. We are not actually generating any new definition of avogram. It's just reciprocal of that. And this value will be there. But AMU has a proper definition. AMU is not reciprocal of 6 point Avogadro's number. Though the numeric value is coming out to be same, but AMU and avogram are two different things. Avogram is reciprocal of that. AMU is 1 by mass of, or you can say 1 by 12th of carbon 12 isotope. And avogram is nothing but it is mass of one atom. Here the definition is 1 by 12th of carbon 12 isotope, and this is considered to be a mass of one atom of that particular one compound here. Students, tell me if that is clear to everybody or not. Students, let me know in the chat box if that is clear to all of you or not. Right? Okay? Okay? This is 1 by 12th of carbon 12 isotope. This is mass of one atom in grams. That's it. You will say, though they are representing the same thing only, but still their meaning is not same. Their definition is not same. Okay, right? That's what I am telling you. Numeric value is same, right? This is 1 AMU. The definition the scientists have given us is this definition. The definition of 1 AMU is not mass of 1 atom in gram. This nowhere it has written. Whenever you will see definition of AMU, the scientist has given the definition that it is 1 by 12th of carbon 12 isotope. And avogram is mass of 1 atom in grams. No doubt they both are indirectly telling the same things, but by definition they are not same, right? By definition you can't say 1 AMU is mass of 1 atom in grams and avogram is 1 by 12th. No, this is definition of 1 AMU, this is definition of 1 avogram, and the numeric value is also same. Okay, understood? Understood? Yes, but the definitions are different. Okay, definitions are different. Chalo. Now let's talk about mole concept here. Okay, till now tell me if there is any problem. Now let's talk about mole concept. Mole concept is in 3 ways, right? One is always it is going to be given by molar, given by molar. This is also given by molar. By molar. Now, one thing is it is in terms of mass. So it is given mass by molar mass. This is given volume by molar volume. This is given particles by molar particles. Now, understand one thing. Given will always be given to you in the question. Given mass, given particles, given volume, this all will be given to you in the question itself, right? But if you talk about molar mass, that you can calculate for any compound, they will give you the name of the compound. You can calculate molar mass of anything. Like how do you calculate the molar mass of Na2CO3? That is 2 into Na, that is 23 plus 12 plus 16 into 3. That is the molar mass of Na2CO3. Right? Similar way, you can calculate molar mass of anything. What is the number of particles in 1 mole? That is nothing but Avogadro's number. So can I just simply write here, this is nothing but Avogadro's number, that is 6.022 into 10 raised to power 23, that is fixed. This particle may change. If they have given here that they are talking about compound, let's say they have given that they are talking about atom, or they are talking about molecule, or they are talking about ions, or electron or proton, according to that the particle that will change. That means if I say I have hydrogen atom, then you are, by putting this same value of Avogadro's number, the value is going to remain the same. But when I am talking about atom, I will calculate the number of atoms. When I am talking about molecules, I will calculate the number of molecules. But this value will not change. This value will always remain 6.022 into 10 raised to power 23. This will always be 6.022 into 10 raised to power 23. If I talk about atom, answer will be atom. If I talk about molecule, answer will be molecule. If I talk about ion, answer will be ion. Electron, answer will be electron. Proton, answer will be proton. Right? Okay. Now, third is given volume. This also be given to you in the question. But molar volume, that actually varies. Usually you take molar volume as 22.4 liters, right? But there are other values as well that you have to see here, right? If nothing is given, if no specific thing is given, no specific thing is mentioned, like they have not mentioned anything specially that this is the temperature, they have just written at STP, or they have not even written STP, right? Then you will take the molar volume as 22.4 only. But what if they have specially mentioned that standard temperature is 0 degree or 273 Kelvin and 1 bar is the pressure, then it will be 22.7. Very rare cases this happens. Very rare cases they can give you actually this. but we can't take risk, right? We are preparing for a solid preparation of NEET we are doing, right? If they are saying 25 degrees Celsius and here 1 atmospheric pressure, then it is going to be 24.5. But if nothing is mentioned, you will take 22.4 only, that we take in our usual cases, right? Okay, now let's understand this with the help of an example. For example, this I am talking about standard conditions. If I talk about helium, right, one atom of helium, this means 22.4. If I am saying that this all is 1 mole, this is also 1 mole, this is 1 mole, this is 1 mole. If all of them is 1 mole, here you will have 22.4 liter of helium atoms. The volume will be in liter. The volume occupied by helium atom is 22.4. Pressure is 1 atmospheric, temperature is 0. Mass of the gas will be molar mass, that is 4 grams, right? Number of gaseous molecules will be gaseous. Here it will be atoms. Okay. In this case, it will be molecules. In this case, it will be molecules. In this case also, it will be molecules. Volume is same, temperature, pressure, mass in 1 mole will be equals to the molar mass, right? And this much atoms, right? That is same as Avogadro's number. Similarly here, volume is molar volume, atmospheric pressure 1, temperature 0 degrees Celsius. Mass occupied here is nothing but the molar mass, that is 16 gram. And how many molecules you have, that is Avogadro's number of molecules. Okay, clear everyone? Shall I start doing the questions now? Everybody, let's start doing the questions now. Okay, are you all ready for the questions, students? Are you all ready? Ready for the questions part? Okay, let's do this. First is, a piece of copper contains this much atoms. How many moles? A piece of copper, this is given in atoms. That means the formula of moles that you will apply is, formula of moles will be 6.022 into 10 raised to power 24 by Avogadro's number. And tell me, here I am calculating 10 moles. Okay, this much atoms was given and Avogadro's number of atoms are present in the 1 mole. So I got the answer as 10 moles. So a piece of CO2, how many moles it contains? That is 10 moles. Similarly, let's do another question. Here I am just speaking out simple question, then we will do complex questions. Okay, how many moles they have asked you of oxygen atom? See, this is oxygen atom. In 88 gram of oxygen, they are asking you moles of oxygen atom, right? For that, understand one thing. They have asked you oxygen atom, right? So whenever they ask you any other thing, understand one thing, whatever, see, tell me, whenever you are in trouble, whom you call? You always call your mummy, right? Mom, I need this. Mom, I need that. I don't know, where is my wallet? Where are my books, mom? What's the lunch? What's the dinner? Always call your mom for everything. So here we will call whom? We will always call moles for every single problem. Every single problem will be answered by moles throughout your today's lecture. In the next lecture also, we will focus entirely on moles, right? Okay. So moles will be moles of, this is mentioned by N, of CO2 will be, mass of CO2 is 88. What is the molar mass of CO2? That is 44, right? How you can calculate the molar mass? This is nothing but this is 12 plus 16 into 2. Answer will be 44, right? Now you have 2 moles of CO2. Now you will apply unitary method. How? You will say 1 mole of CO2 has 2 mole of oxygen atom, right? 1 mole of CO2 has 2 mole. See, 1 molecule has 2 oxygen atoms. So 1 mole of CO2 has 2 oxygen atoms, right? So 2 moles of CO2 will have 2 into 2, that is 4 mole of oxygen atom. So answer will be, number of moles of oxygen atom is going to be 4. and that is going to be the final answer here, right? By unitary and mole, these are two important things that you will see in this chapter. Okay. Third question is regarding volume. A sample of helium gas occupies this much liter, given volume this is, at STP. They have not mentioned what is the standard pressure and temperature, so we will take the general value, that means 0 degree temperature and 1 atmospheric pressure, where volume is 22.4 liter, that is the molar volume. How many moles of helium does the sample contain? How many moles of helium they are asking you? How many moles of helium, students? Number of atoms. See, it is given in the volume phase, right? So it will be 5.6 divided by 22.4. That is the number of moles of helium that you will have here. Is that clear to everybody or not? That is going to be the answer for number of moles of helium here. Okay, understood? Very good. Understood, everybody? Now, let's solve this question where they have asked you, currently we are building up our mole concept, right? This kind of simple question is not asked in NEET, right? We are building our mole concept, right? To understand the complex question, you have to firstly go through these questions as well. So, calculate the weight in grams of the following sample. So, one by one, we'll calculate that, right? The first question that is given to you, that is 100 atoms of carbon. See, we know that number of moles in terms of mass is what? Number of moles in terms of mass is given mass by molar mass, and in terms of particles is given particles by molar particles. Here we are talking about carbon atom because C2, no, right? So that's why carbon atom. So that means you have to calculate atom here. So you know the weight, what you know the particles, you know Avogadro's number, you know molar mass here. They are asking you the weight. So you can say that weight is equals to N by Na multiplied by molar mass. Can we write it here? Can you tell me what is the answer? Number of atom is 100, ma'am. 6.022 into 10 raised to power 23. What is the molar mass, everyone? What is the molar mass? Shabash, everyone. Carbon has 12 molar mass. Calculate this and you will get your answer for weight of carbon. That is your A part here. That is A part. Okay? Clear, everyone? Clear, everyone? Now, shall we move to the B part here? I'll start with this particular thing. So, it is nothing but 8 gram of atom of oxygen. Simple. 8 gram of, it's a given only. 8 gram of atom of oxygen. Weight or in gram of the following sample. 8 gram of atom of oxygen. It is there only. I think I say confused, just to confuse you. It is there only, it is given. It will be 8 gram. Na? Weight is given only 8 gram. Right? Last one is 25 AMU. Right? Then you have 25 AMU of chlorine. See, here you can't apply any formula of moles. Why? Because AMU does not have any formula. You have to apply unitary method. You can say that one atom of chlorine has mass 35.5 AMU. That means 35.5 AMU is the mass of one atom. Okay? They have asked you the weight in grams. You don't even need to apply the unitary method. You can just directly put the value 25 AMU. What is the value of AMU? AMU is 1.66 into 10 raised to power 24 minus 24. So you can put 1.66 into 10 raised to power minus 24 grams, and this will be the mass of one chlorine atom. Okay, this will be the mass of one chlorine atom in grams. They have given you in AMU. Put the value of AMU because they are asking you the weight here. Right, everybody? Right? Is that clear? How to calculate the weight? Right? If something is given in AMU, multiply this by this particular value, that is the value of AMU, you will get the answer in grams. Okay, because what will happen in big questions, they will give you something like this. You don't know how to solve it in gram, you won't be able to calculate the moles here. See, if you know the mass here, now you can calculate the moles by dividing it with 35.5, right? Okay. Now, let's see the next one, that is calculate the atoms of 100 AMU of helium. This is NEET 2024 question. Can you believe that? Yes, it was there. That's why the big difference in NEET 2024 and 2025 was there, right? So see, we know that one atom, whenever they ask you the particles or atoms and things are given in AMU, not weight. It is not given in grams. If this was given in grams, now I could have solved it. Number of moles is equals to 100 by helium is 4. Then atoms will be n by Avogadro's number. I could have solved it easily. Multiplying it with Avogadro's number, I would have gotten my number of atoms. But if this was given in grams, this is given in AMU. So one idea is to firstly calculate it into grams. Other idea is apply unitary method, right? That is what you have to do here. Just say one atom of helium has 4U of mass. Mass is 4U, right? That means 4U of mass is in one atom, right? That means, can I say how much 1U of mass will be 1 by 4 atoms? Okay. Then how much mass AMU is given? 100. 100 AMU of mass will be there in 1 by 4 into 100. That is nothing but 25 atoms. So answer is nothing but 25 atoms. Right? Is the answer, ma'am? Yes, that is the correct answer, everybody. That is the correct answer. Okay? Understood? Now, let's move and start doing the previous year questions of mole concept. Everybody, let's do that. So, first is NEET 2025 question that says, among the following, choose the ones with equal number of atoms. So, you have to choose the ones with equal number of atoms. So what you are going to do, simple thing is, you have to calculate equal number of atoms. So number of atoms by Avogadro's number is equals to mass by molar mass. So can I say number of atom is nothing but, because, wait a minute, choose the one with equal number of atoms. See, one thing is very important, that you will calculate here the molecules. One thing is very, very important to understand, that you will calculate the molecules here. This is molecule, so you will calculate the molecules here firstly, right? So N, you can say number of molecule is this thing, right? And now that will be multiplied by the atomicity. That will become your number of atom. That will become your number of atom. Now, can you tell me what is atomicity? Atomicity is number of atoms in one molecule. Like here, number of atom is 3, 4, 5, 6. This is 2, 3. This is 1, 2, 3. This is 1, 2. This is 3, 4, 5. Okay. So, you have to multiply it with atomicity. Mass is given, molar mass is given, Avogadro's number is fixed, multiply by atomicity, and you will get your answer here. Right? Okay. Let's see this. When you will solve this, see, this is multiplied by atomicity, 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 atomicity. Wait a minute, this is also 2, kya? Haan, 2 atomicity. Last one will be, why I have written 5 here? This is 1, 2, 3. Okay? This is atomicity that you are multiplying it with. Avogadro's number is there, right? Mass by molar mass, mass by molar, mass by molar, mass by molar, mass by molar. After solving, what you will see, you don't have to put the value of Na, right? Because Na is same in all of them, right? Solve this in terms of Na. What you will see, this and this are getting the same number of atoms. So A, B, D have the same number of atoms. That is going to be the answer here. What students do, the mistake is they don't multiply it with atomicity. That's why I specially mentioned what is given, you will calculate that thing. So by applying till here the formula, you will calculate the molecules. You will have to multiply with atomicity to calculate the number of atoms here. Okay? Yes, everybody? Is that clear? Okay. Next is calculate the number of atoms, electrons, protons in this. See, from one question, now I am going to teach you the full mole concept. Okay? This one question and full mole concept I'll teach you here. Right? Everybody, this one question is going to be extremely important for you. Right? So what I told you, calculate the number of atoms, electrons, protons in this much of CO2. Right? So number of atoms in general you have to calculate. So this of CO2 is given to you. That means firstly let us calculate. See, one thing to remember always, what is given, you will calculate the moles of that. Then you will apply the formula. Let's say you have calculated the moles here. Right? Now they are asking from this, if you know the moles, from this they are asking the number of atoms you can calculate. The electrons you can calculate, protons also you can calculate. But always what is given to you, you calculate the number of moles first. Whatever, if they have not mentioned it in the question to calculate number of moles, but you have to calculate, right? So number of moles of CO2 is going to be 67.2 divided by 22.4, right? Okay, that is there. Now let's see, I think it is going to be 3, है ना? So 22.4, yes, 3, right? So it is going to be, cancel this and you will get 3. Now, if once you know the number of moles of CO2, firstly they are asking the number of atoms here. We know that number of moles of CO2 is equals to number of molecule, because this is given as molecule by Avogadro's number. So number of molecule of CO2 will be, number of moles is 3 multiplied by Avogadro's number. I'll just write it as 3Na. Okay? According to options, you can put the value of Na here, right? They are not asking you the number of molecules, they are asking you number of atoms. So you will see in one molecule you have 3 atoms, right? So in how many molecules? 3 Na molecules. You will have 3 into 3 Na atoms. That is going to be 9 Na atoms. That is going to be 9 Na atoms. Is that clear? What we are saying, one molecule has 3 atoms. According to that, you will have. Now, in general, it has 9 of these atoms, right? That answer we have already got. What if they ask you number of carbon atoms specially? Then you will say one molecule has 1 carbon atom. So 3 Na molecule will have 3 into Na carbon atom. Right? Now just imagine that they ask you how many number of oxygen atoms you have. Then you will say one molecule have 2 oxygen atoms. See, this is according to the formula. In this formula, one molecule has 2 oxygen atoms. So 3 into Na molecule will have 3 Na into 2 oxygen atom. That is nothing but 6 Na of oxygen atom. Tell me, beta, if that is clear. Okay? Is that clear to everybody or not? Is that clear, guys? Please write something in the chat box. I'm teaching you guys only, right? If that is clear, then kindly write it in the chat box. I will be very happy to see you guys interacting with me, right? Okay, everybody, I'm waiting for your replies in the chat box. Yes, everybody. is equal to this into power 24, when an electron is equals to this into this. Very good, very good, very good, very good. Now let's understand that how to calculate electron protons here, right? See, that will also be calculated by this thing only. So simply we will say that one molecule has, tell me one molecule has how many electrons? Carbon plus oxygen atom. Carbon has how many electrons? Carbon has 6 electrons. Plus oxygen has 8 electrons, and 2 oxygen atom has 16 electrons. So it will be 16 plus this, that is 22 electrons. So you can say one molecule has 22 electrons. So 3 into Na molecule will have 3 into 22 Na of electrons, that is 66 of Na of electrons, right? Now, because this is a neutral atom, number of electrons is equals to protons. You can say number of proton is equal to electron, that is 60 of Na of protons. Okay. But now tell me one thing. If in the same scenario they would have given you CO2 negative, in that case number of electron is not equals to number of protons. Then proton would be same only. Proton is what? Proton is same. Na? Proton you can't take out. In anion and cation, proton you don't take out. You take out electrons. So then number of electrons will be, number of proton will be the same. Number of proton will be 66. Sorry, 66 is it? It's 60 I have written by mistake. This will be 66. 66 Na of proton, right? And number of electron will be what minus? See, number of electrons will not be same, right? Number of electrons will be, one molecule has how many electrons? Here one molecule has 22 electrons. Here you have added 1 electron. So it will have 22 plus 1, that is 23 electrons. So 3 Na of molecule will have 23 into 2 Na of electron, that is 46. Wait a minute. Why here 3, 6? This should be 3, right? Okay, 3, 3. 69. 69 Na of electrons. Okay, everybody? Yes, everybody? Clear? Clear now? Now, you know what you would have also calculated if they would have asked you to calculate, let's say they ask you to calculate the volume here. Let's say instead of atoms, they are asking you to calculate the volume, or you can say they are asking you to calculate the chalo, let's see firstly if they ask you the volume of CO2 gas. So that will be volume of number of moles of CO2 is equals to volume of CO2 divided by 22.4. So volume of CO2 will be equals to 22.4 multiplied by number of moles is 3, right? Let's see if they ask you to calculate the mass of CO2, right? Acha, volume is to given to you, so you can calculate the mass here, right? If they ask you to calculate the mass will be, we know that number of moles of CO2 is equals to mass of CO2 divided by what is the molar mass, that is 44. So mass of CO2 will be equals to number of moles, that is 3 multiplied by 44, that is going to be the mass of CO2 in 67.2 liter. Okay, is that clear to everybody? Right? Now, by just this one thing, so many things we are able to calculate. That is the beauty of mole concept, right? They can ask you anything from one thing. That is the beauty of mole concept, right? Now, let's do this question. Calculate number of ions in 0.1 moles of AlCl3. Number of ions they are saying. See, we know that firstly calculate. If you see, this is dissociated into Al3 positive plus 4Cl plus 3Cl negative, right? 3Cl negative. So can I say that 1 mole of AlCl3 has how many, like, you know what, instead of calculating 1 mole, just write it there, asking the number of particles. So see, number of moles of AlCl3 equals to number of ions divided by Avogadro's number, right? Number of ions of AlCl3 will be equals to 0.1 Na, right? Now see this thing. No, this is not ions. I'm so sorry. We are calculating the molecule here. Okay, I have not dissociated it now. AlCl3. That means number of molecule of AlCl3 is 0.1 into Na. That is the number of molecule of AlCl3. Right? Firstly, always calculate the number of molecules of AlCl3. Right? You have calculated, because we want to calculate the ions. So we will say in one molecule, you will say in one molecule is dissociated into 4 ions, right? Then 0.1 Na molecule will dissociate into 4 into 0.1 Na ions, that is 0.4 Na ions. So in total, how many ions you will have? 0.4 of Na of ions you will have. If they specially ask you that how many Al3 positive ions, see, one of AlCl3, one molecule has one Al3 positive ion, right? So this much of 0.1 Na molecule will have 0.1 of this ion. So this will be 0.1 Na. See, if this is 1, this is 3. So if this is 0.1, this is going to be 0.3. So 0.3 ions. Al3 positive is 0.1, this is going to be 0.3. Okay? Yes, everybody? Okay, everyone? So much chit chat, talking. You guys have made it some other platform only here, right? So let's talk about these two, I think, questions. Yes, let's talk about, wait a minute. Yes, let's talk about these two questions, guys. Let's talk about these two questions here, right? Everybody, let's talk about these questions. What is the mass of precipitate formed when 50 milliliter of 6.9% solution of AgNO3 is mixed with 50 milliliter of 5.8 NaCl solution? See, you have to see this question very carefully. This is your like pre-COVID pattern kind of question that they can easily ask you. Mass of precipitate in 50 milliliter of point this. See, if solution is this much, now what will be the mass of AgNO3? Mass of AgNO3 is going to be 16.9% of 50 ml. That is 16.9 by 100 into 50, right? So that is going to be 8.45 gram will be the mass, right? If you talk about mass of is mixed with this much of NaCl. So mass of NaCl is going to be 5.8, right? Percent of, that means this much, 5.8 divided by 100 into 50. That is again, this is 5.8 divided by 2, 2.9, right? Yes, everybody, 2.9. Okay. Now what we are going to do, we have the mass, right? Now they are saying that mass of precipitate formed when this and this. See, one simple thing is, if let's calculate the number of moles here, right? Okay, wait a minute. I think this is a question of stoichiometry. It's actually a question of stoichiometry only, right? So let me just tell you how. See, first you will calculate the number of moles of AgNO3, right? Here you will calculate the number of moles of NaCl. I told you how to calculate the mass. Given mass by molar mass you can calculate here. Ag is 108, nitrogen is 14, then 3 into 16, that will be the molar mass of AgNO3. Similarly, mass of NaCl you can calculate. Na is 23, Cl is 35.5. Calculate it, you will get the mass as this is 0.004 moles, this is 0.00, that means the same number of moles you are getting. Now, once you have calculated two things you are adding and you have calculated the number of moles. Now we know that whenever this reaction happens, you have AgCl, then you have Na positive, then you have Cl negative. This is the whole equation here, right? So what they are asking you here is, what the mass of precipitate formed, how much precipitate is formed. Tell me, this is not a precipitate, this is not a precipitate. Precipitate is AgCl. So AgCl is the precipitate that will be formed, right? See, simple thing, see, if you say 1 mole reacts with 1 mole to give 1 mole, this is actually stoichiometry. Stoichiometry means that whenever I talk about stoichiometry, I'll also teach you that in detail in today's lecture only, but let's get a hint of that. Stoichiometry means throughout the balanced chemical equation, right? First, you will write the balanced chemical equation. You will see that if 1 mole of AgNO3 in 1 mole giving you 1 mole of AgCl, then 0.049 mole will give you 0.049 mole of AgCl only, right? That's how you got the mole of AgCl. They have asked you the mass of AgCl. Apply this. Weight will be number of moles of AgCl multiplied by the molar mass of AgCl. Molar mass of AgCl is 108.35.5. Add it and you will get your answer here, right? Okay, that will be your question of this thing, right? That's how you can answer this. That is based on stoichiometry plus mole concept. Now let's see the amount of glucose required to prepare 25 milliliter of M by 20 aqueous solution. You will say, ma'am, this is the question of concentration, is it? No. Right? See how you will calculate. We know that molarity is equals to number of moles divided by volume. If volume is given in milliliters, then you have to multiply this by 1000. That means, can I say number of moles will be molarity into volume in milliliter divided by 1000. Now molarity is given to be 1 by 20. Just put it here, 1 by 20. This is 1000 and volume is given to be 250. Solve it, right? And you will get your answer here. This is 4. So this is going to be 1 by 80, right? Answer of number of moles is 1 by 80. Now we know that they are asking you the amount of glucose. That is, mass of glucose is nothing, you can say mass of glucose is number of moles multiplied by the molar mass. Molar mass of glucose C6H12O6, C6H, wait a minute, C6H12O6, right? So you will calculate, this will be 180. Right? Number of moles is 1 by 80. This is 180. By solving this, you will get your answer. This is nothing but 2, 4. This is 9. So 9 by 4, you solve it. 2 point something is going to be the answer. So you'll calculate the answer as 2.25 gram is the correct answer here. Right? Okay? Understood? Now, this is a question that is not that directly related to mole concept, right? So I would want to solve this question in the end. Or do you want me to solve it now only? Let's solve it in the end only because it's not that related to mole concept, but still I have just taken that question because that was important, right? Now let's understand stoichiometry. So we have done question on stoichiometry. Stoichiometry and mole concept goes hand in hand, right? But now, earlier the focus was less on stoichiometry, more on mole concept. Now stoichiometry, I'll teach you in detail what we are doing, right? So stoichiometry is nothing but that is the calculation based on quantitative relationship between reactant and products in balanced chemical equation, right? That means in the balanced chemical equation, by just looking at the equation, we apply stoichiometry calculations. That means when we see this equation, we say that it's 1 mole of N2 reacts with 3 mole of H2 to give 2 mole of NH3. This is what I am telling you. 1 mole of N2 reacts with 3 mole of H2 give 2 mole of NH3. Will be like, ma'am, perfect. Now here the important catch is this 1 mole is also representing 22.4 liter of volume. This is representing 3 into 22.4. This is representing 2 into 22.4. This 1 mole is also representing Avogadro number of particles. This is representing, this is 3 mole, so this is representing 3 into Avogadro's number. This is representing 2 into Avogadro's number of particles, right? Because in 1 mole you have Avogadro's number. This 1 mole is also representing the molar mass. That means it is representing 28 gram of mass. This is representing, this is 2 into 6 gram of H2. This is representing, this is 14, 15, 16, 17, 17, so 20, 21, 41, right? 83. This is 41 into 42 into this, yes, 84. 84 gram of NH3 it is representing, right? Okay. So by this, can I say that by just looking at this reaction, you have so many things to tell. That is nothing but stoichiometry. By just looking at the coefficients here, I am able to tell so many things. That is the conclusion, that is the application part of stoichiometries. Now we will see how to use this stoichiometry in your exam, right? Okay, with the help of questions, we will see this, right? So the first question is combustion of glucose produces CO2, water. Combustion of glucose C6H12O6 produces, see, combustion means O2, it produces what? CO2 and water. It produces CO2 and water. Now see one thing. Firstly, always in stoichiometry, you have to balance the equation first. So you have to balance this. This will be 6 and this will be 6 also, right? Oxygen, I think hydrogen is balanced now. Carbon is 6, oxygen is 12 plus, no, this is 6, 7, 8. 6 to 12. 12 plus 6, that is 18. So this is 6 only. So you'll have to multiply this by 6, isn't it? This is now 12 plus 6. This is also 12 plus 6. So now this is the balanced chemical equation. Okay. Now understand one thing. Whenever you apply stoichiometry, one rule always remember. While applying stoichiometry, this is the concept. Something will be given in the question. From that given, you will have to calculate the moles of whatever is given to you. Whatever is given to you. After that, something will be asked to you. So you will apply unitary method to calculate moles of what is asked to you. You will calculate moles of what is asked to you. Once you know the moles of what is asked to you, now from there you can calculate anything. You can calculate volume, you can calculate particles, you can calculate the mass, anything you can calculate for what is asked to you. Okay, I'll apply the same method in every single question. Okay, the way of asking the question might change. This is the simplest kind of question of stoichiometry that you have on your screen, right? Now if you see this, this is combustion of glucose produces CO2 and water, right? The amount of oxygen, that means you have to answer this thing. This is something that you have to answer. Okay, this is what is asked to you. for complete combustion of 900 gram of glucose. Now this is given to you. So for what is given to you, firstly I'll calculate the moles. Number of moles of glucose is 600 grams divided by 180, right? Okay. So now after calculating the moles here, tell me one thing. You will have to apply the stoichiometry here, right? Okay, students? Yes, everybody, right? So if we'll calculate 60 by 18, that is coming out to be 3.33, right? So I'm writing it 3.33. Now, what I told you here, after calculating the number of moles of what is given to you, you have to apply stoichiometry, you have to apply unitary method to calculate what is asked to you. So calculate the number of moles of oxygen. Number of moles of oxygen is, see, you will apply unitary method, you will say 1 glucose is reacting with 6 O2. So 3.33 glucose will react with 6 into 3.33 O2. That means number of O2, number of moles of O2 is going to be 6 into 3.33. You can also write this thing. You can also write 60 by 18 into 6. Okay. That will be more better for you because calculations will be less. So rather than writing 3.33, I have just written here directly. 60 by 18. Right? This also I am just directly writing 60 by 18. Right? 60 by 18. 60 by 18. So let's say 18, 3 and this is 20. So number of oxygen is going to be 20 moles. Right? Okay. Number of oxygen is 20 moles. That means number of O2 is 20 moles. They have asked you the mass here. Mass of oxygen will be number of moles multiplied by the molar mass of oxygen is nothing but 32, and that is going to be your answer here. Right? Okay. 960, how you are calculating? 60, 18. Are you sure? 960. Wait a minute. Combustion of glucose produces this amount of this. Incomplete combustion. Oops, I have taken 900 grams. I have taken 600 grams. Oops, my mistake. I have taken 600 grams. This should be 900. So it will be, this will be different now, right? This will be 2, right? So it is going to be 10 by 2. 10 by 2, that is 5 moles, right? Okay, things will be different now, right? This is 5 moles. Answer will be absolutely different. Okay, so let's see this. This is going to be 1 mole will have 6 mole. 5 moles will react with 5 into 6 of oxygen. That means number of moles of oxygen is 30 moles. So mass of oxygen is going to be 30 into 32, right? Okay. Yes, everybody. Okay. Yes. Now the answer is going to be 960 is the correct answer here. Okay. See, by just one single thing, what all, like, the whole question was about to go wrong, right? Isn't it? So don't do these mistakes in your exam, right? There to nobody will also tell you that this is wrong, right? So let's do the next question, that is a mixture of formic acid and this much of oxalic acid is treated with concentrated H2SO4. The evolved gas mixture is passed through KOH pellets, weight in grams. I know that these kind of question is where students are like, ma'am, I can't do this, right? Let's understand this question, what exactly they want to tell you. A mixture of this much of formic acid, one is formic acid is given to you, right? Firstly, I'll not write anything as such, formic acid. And next thing is oxalic acid. I'll just tell you that how to understand the question, okay? If once you understand the statement, you will be able to answer. this much gram, that means here the gram is mentioned, here also it is given to you, okay, is treated with concentrated H2SO4. They are treated with concentrated H2SO4, the evolved gaseous mixture. That means you should know the reaction part here. You should know the reaction part here. You should know evolved gaseous mixture. You should know what are the gases that are present here. You should know what are the gases that are present here, right? What are the gases that are formed? Is passed through KOH pellets. Now, one thing also you should know, carbon dioxide is absorbed by KOH. This is a very important statement that is asked in JEE as well so many times, that KOH will not absorb carbon monoxide if that is formed, or water if that is formed. KOH will absorb carbon dioxide. That you should know, right? Now, this was asked in NEET 2018, which is a good question. Okay, so formic acid, first you should know the reaction. Some gases will be formed, some gases will be formed. KOH will absorb some gases, right? Weight in gram of the remaining product. That means you have to tell, after KOH has absorbed some gases, what is the remaining product that is formed. First, you tell me if the question is clear to all of you or not. Now we will see the answer. See, first thing is you should know the reaction, right? This is formic acid. Formic acid reacts with H2SO4, releases H2O and CO. Now you have to also see that is the reaction balanced or not. One carbon, right? Two oxygen, two hydrogen, reaction is balanced, right? H2SO4 is acting as a catalyst only, so you don't have to worry about it, right? H2CO, C2O4, it gives H2O, CO and CO2. See if the reaction is balanced. 2 carbon, 2 carbon. 4 oxygen, 1, 2, 3, 4 oxygen. 2 hydrogen, 2 hydrogen. Right? Now see one thing. This thing is given to you. This thing. So can you calculate the number of moles here? Number of moles of formic acid and number of moles of oxalic acid, right? That will be given mass by molar mass. So you calculate it, given mass by molar mass, right? But see one thing, this is given in grams, so it will be 2.3 divided by 46. That is the molar mass. You can calculate. See, molar mass is not a big deal. How to calculate? Carbon is 12, oxygen is 16 to 32 to 6, and this will be 46. Easily you can calculate. In the same way, you can calculate for the oxalic acid here, right? Okay. So in oxalic acid, the mass will come out to be 90 here. How? 2 plus 24 plus 16 into 4, 64, right? 4, 4, 8, 9, 10, 6, 7, 8, 9, that is 90. Okay. So that's how you can calculate the molar mass of oxalic acid. Once you know this as well, so I'll just write it here. This is 4.5 divided by 90. You calculate this, you will get your answer. Now see the important part. This is coming out to be 1.1 by 20. This is also coming out to be 1 by 20. Now is the stoichiometry that we will apply. That initially this is 1 by 20, this is 0, this is 0. After the full reaction, we are saying it is fully used up, right? So after the full reaction, 1 by 20, see, if here 1 by 20 you have used, 1 mole is giving you 1 mole. So that means 1 by 20 will give you 1 by 20. 1 mole is giving you 1 mole. That means 1 by 20 will give you 1 by 20. So in the reaction mixture, you have this thing, right? Here also, 1 is giving you 1. So it will be 1 by 20 give you 1 by 20. 1, 1, 1 by 20, 1 by 20. 1, 1, 1 by 20, 1 by 20. So now this is in the reaction mixture. Now I told you that if you pass QH through this, CO2 will be absorbed by QH, right? Okay. And water will be taken by H2SO4. Reverse reaction will be there. Okay. So water will also be reacted by H2SO4, right? And CO2 will be taken by QH. In the end, you will have carbon monoxide only. One is this carbon monoxide you are left with, this, and this is what you are left with, right? So that means number of moles of carbon monoxide is 1 by 20 plus 1 by 20. That is nothing but 20. This is 2, so that is 1 by 10. So number of moles of carbon dioxide that you are left with is 1 by 10. They are asking you the weight in grams. So what you have to do? Weight of carbon monoxide is 1 by number of moles, that is 1 by 10. And what is the carbon monoxide weight? That is 12 plus 16, that is 28. So you can just write it here, 28. That is 2.8 gram will be left in the mixture. Is that clear, everybody? So answer is going to be 2.8 gram is the correct answer in the end, right? Let's do next question. We are left with 3 more questions, right? Let's do that. Now, next is on combustion. Now, this is also a very interesting question, okay? So, this is on combustion of 0.210 gram of organic compound containing this. So, there is some organic compound. I am representing it by OC, or you can say organic compound, okay? Or you can represent it by X. There is some organic compound X which has carbon, hydrogen, oxygen. This is given to be this. Okay. This is on combustion means oxygen. See, any organic compound on combustion give carbon dioxide and water, right? If it has carbon, hydrogen and oxygen, right? Now, we can't balance this reaction because we don't have all the reactants that are present here. That's why we are not able to balance this reaction as such. Now, you'll think that, ma'am, what should I do now? See, that's why I have picked like different questions for you. Not same category of questions are going on here, right? On combustion of this much of organic compound, this is this of CO2. Now, they are saying that H2O formed is 0.127 grams. Carbon dioxide formed is 0.307 grams, right? We have no idea about anything else. Percentage of hydrogen and oxygen they are asking you. See one thing, tell me one thing. The carbon, you have to answer me one thing. Ask yourself one question. The carbon that is here is coming from which thing, which compound? Oxygen does not have any carbon. That means this carbon here is actually coming from this organic compound only. This hydrogen here is coming from this organic compound only, right? That means we can't say that oxygen is coming out only from organic compound. Oxygen is also coming out from this oxygen. But carbon and hydrogen are short coming out of only that organic compound. So if I am able to answer that, if I am able to answer the amount of carbon that is present here, the amount of hydrogen that is present here, then total is given to you. Total, you subtract the amount of carbon, amount of hydrogen, you will get the amount of oxygen. Okay. See, total is given to you. And in this you have carbon, hydrogen and oxygen. They are asking you hydrogen and oxygen, right? See, you can calculate carbon and hydrogen from this data. I'll tell you how you can calculate, right? Once you calculate carbon and hydrogen here, total is given to be 0.210. If this and this you are able to calculate how much percentage is there, right? Then the remaining will be your oxygen, right? Now let's calculate this thing here, right? Let's see this thing here. Firstly, the weight of carbon in carbon dioxide. What is the weight? You will say 12 gram. You can also apply the unitary method here. If you don't want to do directly, you can apply unitary method here as well, right? So you can say that 12 gram of carbon in 44 gram of carbon dioxide, right? 1 gram of carbon is 44 by 12 gram of carbon dioxide, right? How much amount of carbon dioxide you have? You are calculating the carbon, it will be opposite. Okay, you can say that 44 gram of carbon dioxide in 12 gram of carbon. 12 gram of carbon is present. 1 gram of carbon dioxide will have 12 by 44 of carbon. And how much is given to you here? 0.307. 0.307 gram of carbon dioxide will have 12 by 44 into 0.307 of carbon, right? Similarly, you will calculate the mass of the mass of hydrogen present here, right? You will say in water, how much hydrogen? 2 gram of hydrogen is there. So we'll say 18 gram of H2O has 2 gram of hydrogen, right? 1 gram of H2O will have 2 by 18 of hydrogen. And what is given to us here? 0.127. So you can say 0.127 will have 2 by 18 into 0.127 of hydrogen. Okay? You have calculated this part as well. Now see one thing. You know that what is the amount of carbon dioxide. By calculating, you will get it as hydrogen will be something like this and carbon will be point this. Okay? That I have told you how to calculate this and this. Do the calculation, you will get the answer. Now, percentage of hydrogen. See, this is the amount of hydrogen that you have. Total is 0.21. Total was what? Total was given to be 0.21, right? So total was 0.21 multiplied by 100. That will be the percentage of hydrogen in the organic compound. See, understand one thing. This hydrogen that you have calculated here, I'm just writing the values also here. How much hydrogen is there? The hydrogen calculation is 0.0141 and this is 0.0837, right? 0.0141, this is 0.0837. Okay? This hydrogen, right? If you see, sorry, this is the carbon. Carbon that is in this much gram of carbon dioxide is this much, right? That means in this much gram of carbon dioxide, you have this much carbon. That means here also you have the same amount of carbon. That means here you have 0.0837 gram of carbon and you have 0.0141 gram of hydrogen, right? Now total is, tell me what is total? Total is 0.210 gram of compound. Understood that? Once you have reached this point, everything is easy now, right? Now percentage of hydrogen will be this divided by total multiplied by 100. Percentage of carbon will be this divided by 100 multiplied by this divided by 0.21 multiplied by 100, right? I'll also write it here as well. If you see, percentage of hydrogen is 0.0141 divided by 0.21 multiplied by 100, right? Percentage of carbon will be this is 0.837 na? Yes, 0.0210 multiplied by 100. Now percentage of oxygen will be 100 minus percentage of carbon minus percentage of hydrogen. That is the value here. That's how you are going to calculate it. Right, everybody? Okay. Right? Understood? You can expect these kind of questions in your exam. Right? What has happened now? We have to be very, very alert. We have to do good level of questions as well. Right? You can't just do easy questions and say that I know this concept. That will not be valid from now. Right? Okay. Now, let us do the last question of stoichiometry. That is 2 gram of sample contains. Now, this is a very important question. For that, you have to, understand what is happening here. Right? See, they are saying that 2 gram of sample. This is a sample. Right? This contains SiO2 as well. And this contains Fe2O3 as well. Both of them. On a very strong heating, leave a residue weighing this. Now, heating, it gives some residue. The reaction responsible for the loss of weight. That means they are saying the reaction happening is this. That means when you heat it, when you heat it, what will happen here? After this, what will happen when you heat it? In the beaker, now you will have SiO2 and now you will have Fe3O4 and you will have oxygen, right? Okay. This total sample is of 2 gram, right? Now they are saying on very strong heating, leave a residue weighing this. That means it leaves the residue which weighs this. Now we know that beta oxygen will be eliminated because it is a gas, it will be eliminated here, right? That means they are talking about that you will have 1.96 gram of this thing here. That is Fe3O4, right? That means Fe3O4, they are saying it is 1.96 grams, right? Now understand one thing. If I am saying that Fe3O4 is 1.96 gram, right? Now I'll have to, solve this question. How? Let us see how to solve this question, right? They are saying that one thing you should be clear that because this is not 1.96. Actually, they are saying that this whole thing is 1.96. Because after heating, SiO2 is also there and Fe2O4 is also there. That means the amount of oxygen liberated here will be 2 minus 1.96. That is 0.4. Got it? Why I am making the diagram to teach you so that you can understand what is happening here. In the reaction mixture, you had SiO2 and Fe2O3. You heated it, SiO2 remained as it is, Fe2O3 became Fe3O4 and oxygen is liberated. Now they are saying their residue that you are left with, residue means that is there in the beaker, that you have is Fe3O4 plus SiO2, that is 1.96. But what is eliminated here? That is oxygen is becoming a gas, that is eliminated, right? Now understand one thing. What we will say, we want to calculate. If they are asking you what is the SiO2, first you have to calculate the mass of SiO2. What you will do here? Okay, what you will do here? First you will say that first you have to balance this. Okay, this is Fe2. This will be multiplied by 3. This will be multiplied by 2. And this is 3 to 6, 4 to 8, 9, 10. Wait a minute. This is 4 to 8. This is 6. Now this side it is 6. This is 4 to 8. Wait a minute. This is 3. This is 2. 3 into 3. It's a 3, 3, 9. This is 9. This is 9 oxygen. This is 4 to 8 oxygen plus 2. So if I divide it by half, then I'll get 4 to 8, 9 oxygen. That means both sides you will have 9 oxygen. So this is the balanced equation. Okay. Now, if you want to calculate this, what you will say? You will say that you want to calculate actually. What you want to calculate is you want to know how much amount of Fe3O4 will be there, right? You want to calculate that. You want to actually calculate that how much amount of Fe2O3 must be there. The amount of Fe2O3 you want to calculate here. So can you say that? Firstly, what is the molar mass of Fe3? Molar mass of Fe2O3. That is 56 into 2 plus 16 into 3. Okay? Calculate this, the answer will be 480. The answer will be 480. Okay? Now what you will write here? You will say that from this reaction, I will also write the reaction here. 3 of Fe2O3 give rise to 2 of Fe3O4 plus half of oxygen. You will say that 480 gram of Fe reacts with 16 gram of oxygen, right? Because half of oxygen is 16 gram, that is the mole concept. right? This much, this is the molar mass. This much molar mass reacts with this much oxygen, right? That we are clear with, right? In general, this is the mass that is reacting. Na? See, now understand one thing, this was not the molar mass. Hai na? Wait a minute, let me just calculate the molar mass here. Molar mass of this will be 56 multiplied by 2. Hai na? 56 multiplied by 2 plus 48, 160 multiplied by 3. Yes. This will be 160. Okay, this will be 160 gram per mole. Wait a minute. So, if I see this will be 160 multiplied by 3, that is 480. This will be 1 by 2 multiplied by 32, that is 60. That's how I am writing it. Okay. So, if you see this, 48 gram of iron reacts to give 16 gram of oxygen, right? That means 16 gram of oxygen will react with 480 gram of Fe2O3. Okay? That means 1 gram of oxygen will be 48 divided by 16 of Fe2O3. Okay? We want to calculate how much amount is there. That you can calculate from the stoichiometry, Fe2O3. Because this whole thing I did to calculate the O2 here. That is coming out to be 0.4. That O2 eliminated is 0.4. So that means in the reaction, they have eliminated 0.4 gram of O2. So 0.4 will be 480 divided by 16 multiplied by 0.4 of Fe2O3. Let me know if that thing is clear to you or not. Let me just see this 480, because right now, let's not get into calculations too much. Yes, that is important, but for us, we'll focus on this thing, right? Wait a minute. 480 divided by 16 into 0.4. 480 divided by 16 into 0.4. 0.4 na? 0.4 only. 160 gram. This is 480 gram. 480 gram of this reacts with this. 16 gram is this. 1 gram will give you this. That means this much will give you. Wait a minute. What is the mistake? Acha. I have subtracted here wrong. Okay, I'm so sorry. This will be 0.04. My mistake, that will be 0.04, not 0.4, right? So this is 0.04, so this will also be 0.04, right? So that will be 0.04 and this will be multiplied by 0.04, right? So 30 multiplied by 0.04 you have to do, right? That is 1.2. That means 1.2 gram of Fe3O4 you have. So see students, if you are saying that Fe3O4 is 1.2 gram, Fe2O3 is 1.2 gram, right? So if I say in the full sample, you have SiO2 and you have Fe2O3. This is 1.2 gram. Full sample is 2 gram. So this is going to be, SiO2 is going to be 2 minus 1.2, that is what? 0.6, right? That is 0.6 gram of SiO2, right? Now percentage of SiO2 will be 0.6 divided by total is 2 multiplied by 100. That will be the answer that you will have here, right? Okay. So I think 30% will be the answer, right? 30%, 65, 40, 40%, 65, 40%, okay? 40% will be the answer here. Okay, everybody, right? Hanji, clear na? 40% will be the answer. Now, one question I told you that we will do in the end. That was this one. So it's a very, very simple question. Very simple. What fraction of FP exists as? Now, this is not directly related, but it's an important question. So it's related to some basic concepts only. Right? It's a general question. What fraction of FP exists as FP3 positive in this? So now they are asking you fraction of FP exists as FP3 positive in this much. Now total iron is 0.96. If I assume Fe2 positive is, let's say I want to assume Fe3 positive is X, then Fe2 positive will be 0.96 minus X, right? Now, if total Fe is 0.96, if I assume that Fe3 positive is X, then Fe2 positive is 0.96 minus X. Total minus X will be Fe2 positive. Now, if you see the charge, the positive charge will be 3 into X plus 0.96, or you can even calculate the opposite, right? That's totally your choice. Okay? Otherwise, because in this table it is mentioned opposite, then you will assume that, ma'am, why you have done this to us? So let's assume Fe2 positive as X and Fe3 positive as 0.96 minus X. Okay? It's totally your choice. It is not going to make any difference. Okay? So you assume this is 2 multiplied by X plus this is 3 multiplied by 0.96 minus X. This is the total positive charge. Can you tell me what is the total negative charge? Oxygen exists as O2 negative. So negative charge is -2. Right? So can I equate these two together? Once I equate positive charge is equals to negative charge, then I'll have the value of X here. Okay? So once you calculate, you will see that when positive charge is equals to negative charge, you will have the value of X that will be 0.88. That means Fe2 positive is 0.88 and this will be 0.96 minus 0.88. That is going to be 0.08. That is going to be 0.08. Okay? It is not at all related to mole concept. Okay? So yes, the thoda sa it is related, but not that much. Right? So it is X you have find out. This is your Fe2 positive. This is Fe3 positive. They are asking Fe3 positive. That will be this divided by total. Total is 0.96. They have asked you only the fraction, not the percentage. So you will not multiply it by 100. If they ask you the percentage, you will multiply it by 100 and that will be the answer. Okay, right everybody? And that's it for today's class, right? And this is, guys, your homework. You can see this here and I would love to see your homework in the comment section as well. You can see and just take the screenshot. Tell me the answer in the comment section. This is the first question. This is the second question of SI unit of Avogadro's number. Take the screenshot and let me know the answer in the comment section, right? And guys, this is our official Telegram channel where we are providing you every single content of your NEET preparation that is needed. You can also talk to us on comments. And here, students, in the description box, first is I told you about the Hyderabad and Chennai event here, that is over here, right? You will see NEET selection guarantee program at our offline center, that is Hyderabad and Chennai, right? Where our team is visiting. They will do the counseling, especially that whether you will want to take, whether drop is beneficial or not. And if you decided to take drop, we will be giving you guarantee that your rank will be improved. Otherwise, 100% fees refund will be there, right? So all the guidance will be there. If you want to call and see, it will be 5th July is Hyderabad and 6th July is Chennai, right? Okay. So depending upon that, according to the cities that you are living in, you can fill the form here. This is the form for Chennai. This is the form for Hyderabad. But before, like if you have not filled the form, you will not be allowed, right? So you have to fill the form here, right? And students, this is our DNA NEET 2026 batch. As you can see, this is for the droppers and 12th going students, right? Where we are teaching you in 4,999. Now the price has increased to 4,999, right? Yesterday it was 3,999 and the price is going to increase, right? So that's why I'm telling you, don't waste your time. You're wasting your time, you're wasting your money, everything, right? Because you're not on the right path, right? So we in this batch, we are guiding you, we are taking live session, doubt classes, doubt sessions are taken, and then quizzes are asked in the class, leaderboard are asked, mock tests are taken, test series are provided to you, everything, whatever you need is there in the batch, right? Tattva modules are provided to you, all India test series is provided to you. So all the things are there in the batch at just 4,999, and these kind of short notes QR cards are also there in the batch itself. And those students who want to go for pro batches, right, then you can always see this here. Wait a minute. Yes, because on pro batches right now, off is going on. For 2 year it is 20,000. For 1 year pro batch it is 10,000 off is going on, right? Okay, yes everybody. And that's it for today. Thank you so much, Riya, Christian, Priya. Thank you so much. Okay, then, students, bye bye. Take care. See you all in the next class. And I would love to see your comments in the comment section. And do like this session, share this. I want you guys to make the likes by 200 plus, right? Let's make it, right? Let's make it. I'll see this session. I want to see around 30 plus comments here, right? And where I also want to see your homework. I want you guys to share it with your friends, with your juniors, with your seniors, right? Okay. Okay then, students, bye bye. Take care. See you all in the next class. Bye bye.